Dear students, we are back to the class of geometric design. So far we have been discussing about the alignment design, and in the case of alignment design we have talked about the horizontal curve, and then we started with the transition curves and we completed that particular interaction. But within the transition curve we have two cases. One is that instead of having a circular simple curve, we may have a compound curve, or there may be a condition because of the terrain that the curve is going to be a reverse curve. That means the radius or the point of turning which is going to be there, they are on the opposite side of a tangent. So, towards the late in the previous interaction we were discussing about the compound curve, and what we have talked about is that in that case if you have to find out the length of the transition which is to be provided between the two curves which are taking a turn on the same side of a tangent, then that is going to be a difference between the length which is required for the two different curves. So, in that particular sense, towards the end what we were discussing was that what is going to be the minimum length and how the things can be calculated or can be provided. So, what we discussed towards end was that the smooth transition between the curves, the minimum length of the transition should be at least 150 times the difference between the full super elevation of the two curves. So, one length we have already talked about, which is a difference of the lengths which is required for the two curves. So, that was one case, but the another case is that the minimum value which needs to be there is 150 times the difference between the full super elevation of the two curves. So, this is another case. So, that becomes case 2. And the third thing which is there is, it says that at least 30 meters has to be provided or inserted between the two curves if even you found that the lengths are going to be less than that. And if this is being done, then the movement, the transitions which are going to be there on those two curves, they are going to be much better in terms of the driving, in terms of the steering of the vehicle, etc. Then the another point which we discussed was, because we have two curves and we are going to have one curve maybe like this, and then the another curve if the tangent is being provided in this form. So, there are two curves in this way with a radius r1 and r2. So, there is a criteria for that also, and it says that, and we have discussed about it when we discussed about the general guidelines related to the horizontal curves, that the r1 to r2, if r1 is a flatter one, then this ratio it shall be 1.5:1. That is the limiting value which is there, and that is what is being talked here also, that it says that a difference in the radius between the two curves shall not be more than 1.5 times the radius of the sharper curve. If it is more, then it will result in the sudden change in the curvature, because now the difference is going to be quite high in that sense. But if the difference is less than 0.5 times, then the length of the transition curves comes out to be less than 30 meter. Then change in super elevation as required shall be effected on the flatter curve. In such a case, the transition may be omitted. So, this is another case now. So, we are talking about different conditions. So, here one condition was with respect to 1.5 and another condition is with respect to 0.5. And the minimum length which always has to be provided is 30 meter. This is also being decided and being documented here. Now, let us look at one example in this direction. We have a compound curve, and here the curve radius is 500 meters and 350 meters. So, these are the two values which we have. The curve is to be designed for a speed of 80 kilometers per hour. We have to calculate the length of the transition curve which needs to be provided between two circular curves which are there and which are constituting the compound curve. Now, if we remember and if we go back to what we discussed in the previous interaction, then we talked about this formula where it is the difference between the length of the transition based on the rate of change of centrifugal acceleration. So, 0.0215 v cube divided by c into RC2 minus 0.0215 v cube divided by c into RC1 is what we are talking here, where v is in kilometers per hour, c is a constant factor which is defining the rate of change, and RC is, or RC1 or 2, they are the radiuses. Now, as far as c is concerned, then we have to calculate the value of c. The formula is there, which is 80 divided by 75 plus v, again we have discussed about it. So, if we put the values here, what we get is 0.5161, and what it says is the c at the minimum level can be 0.5 and at the maximum level can be 0.8, and therefore, this is a OK condition, we can work with 0.5161. So, if we place all of these values, what we get is 18.28 meters as the length, and the minimum length which shall be provided, absolute minimum is 30 meters, even if we are going to get a lower values than that. So, that is how we can solve it. There can be other checks also which can be implemented on this, depending on that what are the ratios of R1 and R2, as we have discussed in the previous slides. Okay. So, you can also look at in terms of the rate of super elevation which is there in the difference of that multiplied by 150, and all those things are also there. So, if they are the values which are available, we can also examine and find out that length. Now, let us look at another case where the reverse curve is there, and we have to see that whether the transition is being provided or not. So, one curve is there with the radius R1 and there is another curve with the radius R2, but they are both at a opposite direction of a tangent, and that constitute a reverse curve. So, in this particular case, how we are going to calculate the length is what we are going to discuss. So, in this case, the length of the transition curve shall be the sum of the lengths required for both the reverse curves. So, if we talk about the same equations which we have discussed previously, what we are going to get is LT1 and LT2, which is again as 0.0215 V cube divided by C into RC1 or C into RC2, depending on L1 or L2. And if we take the sum of that, then we are going to get this equation, or we can also say that in this case it is nothing but 0.0215 into V cube divided by C and 1 upon RC2 plus 1 upon RC1. So, we can also write it in this form. So, let us look at an example on this particular case also. So, we have again the same conditions, say we have the values of R1 and R2, which are being given as 500 meters and 350 meters, and we have the speed for which it is to be designed is 80 kilometers per hour, and because these are a reverse curve being provided. So, let us look at the length, and the length is nothing but the summation of the length being found for the two curves. Again, if we put the values of all of these things, as we have just taken the same values as we discussed in the previous numerical. So, we get C as 0.5161, and finally, the length comes out to be 103.60 meters, which is much more than 30 meters, and that is where it is OK. So, no other condition is being given. So, we can say that OK, this is fine, and we are going to provide probably 104 meters as the length of the transition curve between these two curves. Now, once we have discussed about the transitions, the next thing which we are going to talk about is a overall changeover, and this changeover is in terms of a vertical alignment. So, horizontal alignment is now discussed completely. We talked about the horizontal curves, we talked about extra widening, we talked about super elevation, we talked about transition curves. So, everything is being covered. Now, let us move into the vertical alignment side. Now, when you are talking about a vertical alignment and you are going from a location A to location B, which is having a height h difference, then there may be a possibility that we are going maybe in this form, so as to reach the another city in this particular terrain where the difference in the elevation is continuously going on. Now, when this happens and when we are trying to connect different points in this form, then we can say that this is 1 in N1 or 1 in N2 or 1 in N3 and so on, or they may be same at different points also. So, whatever these things we are talking now, we are going to talk in terms of the gradients which are provided in the longitudinal direction. Mind it that these are different than those which have been talked in terms of a cross slopes being used. So, define the terrain conditions. So, gradients are what? The gradients are required to scale differences in the terrain between two connecting points, as already being enumerated or as already being defined in this particular sketch or a diagram. This can be defined in different forms. They can be defined as rise or fall along the longitudinal direction. They can be defined as a unit per length, that is 1 in N. They can be defined as percentages, 2% gradient, 5% gradient, 7% gradients. They can be talked in terms of angle, they can be talked in terms of inclination. So, there are different ways in which these gradients can be looked at. So, when we say that we are going to talk about this, it can be this theta, it can be rise h, it can be 1 in n. So, that means this is 1 and this is n, okay, and they can be in terms of percentages. So, this 1 in n can be converted into percentage. So, we get some say x percent. All of these things are possibilities, and these grid lines, when they are provided and we talk about the provision of a curve, say you may have this type of an upgrade, and there may be a possibility that after some time you have a downgrade, because the terrain is undulating terrain and you have to fix the things with respect to the terrain. So, if this type of thing is going to happen, then obviously you are going to ease out the situations at this point by the provision of a curve. So, when we do this provision of a curve, these grid lines which are there here, this is also a grid line and this is also a grid line. So, these grid lines becomes nothing but tangent to the curve, and the same way as we talked previously, we are going to get some deflection in this particular direction, and that deflection is going to be talked as maybe capital N, or any other notation can be utilized for that. Now, when we are talking about these gradients, then there are three categories of gradients which are usually used when we try to connect one location with respect to the another location. What are those three gradients? The first one is a rolling gradient, the another is limiting gradient, and the third one is exceptional gradient. Now, depending on the the conditions, the type of the roads which you are working with, say you are working with the local roads, or you are working with the rural highways, or you are working with the multi-lane highways or expressways, there may or may not be the values for all of these three categories of gradients. So, let us talk about first of all what is rolling gradient. Now, rolling gradient is the one gradient, by the name itself it says it rules mainly. So, that means in most of the type of conditions we are trying to work with this particular value. So, when we say that this particular value is 1 in n1, so this is the mostly used gradient which is going to be utilized for connecting point A to point B. Say there is a possibility if we can go with this one in this form, but subjective the condition is that whatever vehicles which are moving here. So, we have the vehicles which are going in this direction at a certain speed v. So, is there any performance reduction when the vehicle moves on this particular gradient? So, when the vehicles are moving on these gradients, longitudinal gradients, there is no issue in terms of the reduction in the performance. So, if the values have been restricted up to such condition that it is not going to create much of a problem to the vehicle when it negotiates this particular gradient or traverses this particular gradient, then that is what is defined as a rolling gradient. And this rolling gradient is also used so as to define the resisting length. Now, say we are talking about a terrain condition, say something like this. Okay. So, you have the contours, you have this point A here and point B is at the top of this portion, and you are continuously increasing in height when you go from outwards to inwards. So, there may be a possibility that you are not in a position to connect these 2 points in this form, and therefore, what you will try to do is you will try to connect it maybe in this way or in this way or in this way and this way. So, there is a possibility of having these type of connections. So, when we are talking about these type of connections here, so in this particular case why we are doing it, because if we go otherwise the conditions are so steep that your vehicle will not be able to negotiate on that particular gradient. So, if we are using this rolling gradient so as to find out that comfortable length, then what you may have found is that though these point A and point B here, they are just aerially at a distance of d, which is a aerial distance, But if you talk about this particular condition, then it culminates into this B dash. That means now what you have is D 1, which is coming out based on ruling gradient. And if you get this type of a length, then this length D 1 is being defined as resisting length. So, that means we should try to do it, but then there is another issue. We have to see the economy also of the construction. We cannot keep going and increasing the lengths of the roads in this form, so that we remain always in this particular category of the rolling gradient. So, there are certain conditions that say, instead of going this way, if I have gone here and then gone this way and that, probably I could have reduced the length of this particular alignment. Now, when I am going in this direction, this particular case, this is having a gradient which is 1 in N2, which is greater than 1 in N1. But whether this is traceable or not, whether it is traversable or not is another point. So, if we talk about that in that particular direction and say, if traversing of such particular gradient, it causes some performance issue, but which is not substantial, then we may utilize this 1 in N2 so as to reduce the length now, and that is what is going to become a limiting gradient. So, this is used where the topography causes use of higher gradient, and ruling gradient may increase the length and cost of the project. And I hope I have been able to make you understand that how this is going to happen. But there can be few instances where even the limiting gradient is not sufficient. So, you need to provide a further change in the elevation in a shorter length. So far what you have been doing, that you was providing the connectivity in this form. So, we are 1 in and 1 which was ruling gradient. Then we said no, there is a requirement to go to some other value, and that value was 1 in N2 which was limiting gradient. But in some cases it may happen that you have to further go to some another value which can be 1 in N3, and this 1 in N3 is going to create a problem. So, that is the reason we say that this is exceptional case, and that is the name exceptional gradient. So, we have this exceptional gradient which can be provided under only the exceptional topographical conditions, and they are provided not for a long lengths, they are provided only for short lengths which are not more than 100 meters at a stretch, because there is going to be a substantial reduction in the performance of the vehicle if we are going to provide longer such stresses, because there is more of a stress or a pressure which is going to be there to just traverse that gradient. And when you are going to have successive such things, means the one single locational exceptional gradient is not going to work, in that case then successive conditions, if they are there, they are separated by a minimum length of 100 meters. So, it means you are going to have exceptional, and then you just may have something like a flatter gradient and then again an exceptional. So, this is also all of these things. If I talk in terms of lengths, then this is 100 meter, this is 100 meters, this is 100 meters, they are all going to be this way. Now, when we talk about this particular section between the two exceptional gradient, what it says is that we should have either a flatter one, or the other condition can be that we can provide it exceptional like this and then an ease out and an exceptional like this. So, when you provide this ease out gradient where it is going down, it allows the vehicle to regain the power, to regain the speed with which it can move. And sometimes this can also be defined as a sort of a, in terms of railways, where we say that it is a momentum gradient. So, when the train goes in this direction on a downward gradient, along with the component of the weight and the power working in the same direction, it gains more speed, and then it utilizes that speed to traverse this exceptional gradient. The similar thing can happen here in the case of road vehicles. Now, what are the values which are going to be there for the gradients? Let us talk about that. So, in the case of rural highways, we have different categories of terrains. The first one is the plain and rolling terrain, another one is mountainous, and in the case of steep we have up to 3000 meters altitude and above 3000 meter altitudes. For these four cases we have three gradients: ruling gradient, limiting and exceptional gradient. The values are 3.3%, 5% and 6% when you go in this direction. Similarly, the changes, and it starts with 5% and remains 6 and 6 and then becomes 7% in the case where it is steep above 3000 meter altitudes, and becomes exceptional with starting with 6.7 and remains 7 and 7 and then becomes 8% in the last category. So, what you can see is that these two things, they are going to be transferred in this form, and then on the basis of this transferred values, now this is being transferred and this is being revised a bit and we are getting it these things. Here we are talking about the gradients. Now, gradient values, they have been defined for 2-lane, 4-lane and 6-lane highways. Previously the values were different for these different categorizations of the roads, but now all of them have been brought together and we have ruling gradient and limiting gradient. We do not have the exceptional gradient value in these three cases, and the terrain classification, they have been talked as plain and rolling together and then mountainous and steep. The values in the case of ruling gradient, they varies from 2.5% to 6% going in order. Similarly, in the case of limiting gradients, the values changes from 3.3% to 7%. So, this is how the gradient values are changing for the three categories of highways. Now, in the case of expressways also we have only two values of gradients, one is ruling, another is limiting. And the terrain now, if you remember, we have talked only for plain and rolling terrain, accordingly we have the design speeds etc. So, they are 2.5% and 3% and 3% and 4% respectively as ruling and the limiting gradient for the two terrain conditions. So, here the things are quite eased out, as you can see, because in the case of expressways that we are saying that we need to have a more of mobility. So, therefore, these particular gradients, they are not going to make much of a difference to the performance of the vehicles, and the vehicles will keep going with whatever speeds they are utilizing, which may be 80, 100 or 120 kilometers per hour as being used for the design of those expressways. Now, when we talk about the gradients, and we have been talking about that the vehicles are going to move on that, the another important thing which needs to be talked about is the minimum gradient. This is also an important aspect. Now, when you look at the minimum gradient, and this minimum gradient is going to be governed by what? It is going to be governed by the drainage condition. Now, when we are looking at this drainage condition, then it gives you two values, one is desirable minimum, another one is absolute minimum, and depending on that what type of element is there, say it is a curved pavement or it is a side ditch which is lined inside, the desirable minimum remains 0.5%. But if there is a problem in that, because it is going to make a big difference along the total length, then in some cases we can reduce these values, and the values can be reduced in the case of curved pavements to 0.3% and in the case of side ditches to 0.2%. So, these are important things which we need to take care of when we are designing any element, when we are designing anything related to the road, and the drainage has to be taken care of. If this is not being taken care of and the values goes below this, then there is going to be a ponding of water on the surface, and this is detrimental. So, as I said, the minimum gradient is decided based on the drainage considerations. In case of lined structures, it is taken as 0.5%. For unlined structures, in general it is being taken as 1%, and the same is applicable for the drains too. Absolute minimum as 0.3% even for pedestrian paths, and for lined drains 0.2%. So, we have discussed about it already. Now, there can be some typical conditions in which we have to take a decision that how things have to be tackled. So, you are going into a hilly terrain and there is a requirement of providing a culvert. So, there may be a small culvert or a medium size bridge or a big size bridge, depending on what type of drainage pattern is there, or a big nala is there or a river is there, whatever it is. So, in the case of isolated overbridges in flat country or on roads having high traffic volume of slow moving traffic, it is desirable to adopt a flatter gradient of 2% considering aesthetics, traffic operations and safety. So, this is another thing which is being defined irrespective of that whatever we have discussed about for 2-lane highways, 4-lane highways, 6-lane highways etc. This is an additional thing. So, if we have a overbridge, isolated overbridge which is in flat country, means you are more or less in plain and rolling, or the roads having high traffic volume, and this high traffic volume is with respect to the slow moving traffic. So, you have non motorized traffic or you have bullock carts etc., or there may be even tractor trolleys which are there which are not moving at a high speed. So, all of those things are there, then we should go for a flatter gradient, and this helps in terms of all of the aspects. When you talk about the pedestrian ramps, then it is 10% as a maximum, not minimum. This is a 10% as maximum, and in the case of cycle tracks it is 3%, and this 10% these type of things are basically going to be on ramps, not otherwise. In urban areas, considering the mixed traffic, the pedestrians and non-motorized traffic at the junctions, it is desirable to limit it to 4%. That is what I said, that in the case of ramps only we are going to talk about 10%, but in the rest of the facilities we try to keep it as minimum as possible and desirably not beyond 4%. So, that is what we are talking in the urban areas or in the mixed traffic conditions. At intersections, the levels shall be flat as far as possible. This is another aspect. Okay, so, you have an intersection, you are coming with this type of a gradient, or there may be a gradient going in this way and there is a road which is like this. So, as far as possible we should try to have a flatter thing in this particular area. The rise in elevation over a length of 2 kilometers shall not exceed 100 meters in mountainous terrain and 120 meters in steep terrain. This is another aspect. So, you are continuously going, you are continuously increasing the height. So, we are talking about this particular thing at a length of 2 kilometers, we are talking that this can be 100 meters or 120 meters as a change depending on the type of the terrain. But then if it is happening, then you can get the rate of gradient which is going to be provided in this case. So, once we have these gradients and these are essential things to be provided, and as I said that if we have the two gradients, we are not going to work with this type of a kink. This kink has to be changed in terms of a curve, so that the movement remains very smooth on these type of transitions. So, when we are talking about this, it means there is a requirement of providing the vertical curves, and these vertical curves are provided in the vertical profile where there is a change in elevation of different points in the opposite directions. So, we need to look at that how this is happening, or there may be a change in the direction at certain angle, that can also be a possibility. The movement between points at different elevations is through gradients, and those gradients or grade lines they are going to work as tangents. The change in two successive gradients shall be made smooth, and this is done by way of the provision of the vertical curves, and that is how we omit the possibility of having a kink which otherwise may cause a jerk, and the driving of the vehicle becomes much smoother in this case. As far as possible, the long sweeping lengths shall be provided at all grade changes. So, this is another thing which needs to be taken care of. So, we are going to talk further about the vertical curves. So, we can close our discussion here, and we will be continuing with the rest of the things related to the vertical curves in our next interaction. Till then, bye and thank you to all of you. So, we will meet again.